All right, class. So we have our little RC car. Mine might look a little different from yours because I'm running just a slightly different pattern. I have a different battery pack, but essentially it's all the same. We have the same wires coming from the motor controller plugged into the digital pins, digital pin 5 through 10. And then we have our power coming in from the battery pack going into our motor controller and our board right here on the V in. Same with the grounds. Our ground coming from the battery pack and our ground being grounded on the board as well. Oh, sorry about the camera there. Anyways, so the only thing we are adding here, also we have the two wires for the motors that are coming in. The only thing we are adding here is this circuit for that IR sensor. And I have mine mounted because there was just some holes and I had some tiny screws. But for now, on yours, I'd highly suggest using some tape or hot glue and just gluing it onto the surface right there. Something that's removable, just in case if you ever want to remove it or do something different with a different project. But hot glue might work, tape might work, but just mount that to your board like that, and we're going to end up running the same circuit like we did with this board. I have these plugged into D2 for the Y, and I have my red R, which is red for me, plugged into IO ref. And IO ref, we're using that. It's putting out 5-volt logic or putting out 5 volts, but we're kind of using it a little improperly right now. We just need a pin that puts out 5 volts, and we're going to just use that IO ref. And on your board here, some boards like this one I think is labeled 5 volts on that pin, but just use that IO ref. I don't know if I can show that to you there. Too many wires in the right way. Anyways, it's this pin right here. This pin right here where this lead's plugged into. IO ref from R. And then G is just plugged into ground. So again, Y goes to digital 2. R goes to IO ref. And G goes to ground. And so once we have that, we should be good to go. And we have our circuit running. And we're going to jump over here and we're going to program this and so that we can use our little remote to control this thing. So we'll jump over to the coding side right now. All right, class. So I just have a new sketch pulled up here. I already saved it as IR remote RC car. So it'll continuously save, but we're going to combine both those codes that we had before. So we're going to use about, I would say, a quarter of what we had with the RC car thing, with the joystick, and some other stuff that we used with the signal for the remote. But then a lot of this is just going to be new code. So I'm going to go ahead and just start here I have some comments started out here. I'm just going to completely replace this. You can follow along, but we just have the two-wheel RC car. We're running with the NEC remote on our Arduino Uno board, and we have. Oh, where's my remote? Well, I don't have it. No, I got it right here. So we have up as forward, down as reverse, and right and left will spin in place, and then OK should stop the car. Our wiring for that IR receiver, we already talked about this, but I just wanted to clarify that we are using D2 for that signal wire. And we're going to go to 5 volts if you have it available, or IO ref is the other one. So we have the jumper. This is already, we already did this in the past with our joystick, so we don't really have to worry about the bridge, but other than that, we're going to have this when we hold forward, hold down. It's going to repeat that code and keep the car moving. If there is no signal for a long time, we're going to auto stop. That's a fail safe. So that's what I just wanted to point out here with the holding the button. Other than that, we're going to go ahead and start here, but we're going to go ahead and bring up that library that we already included in the other code, because we're going to have to end up using that as well in this code. So that's the hashtag include with the less than or greater than symbols, and we've got the IR remotes.hpp, just like that. And then we have the int for our IR. We're going to call it IR like we did in the other one. Pin, and we're going to close that. And I'm just going to say, just going to label these things properly so that we can keep this going here. And then this is our IR library that we want in here. And so I'm just going to put some enters down here so we move this up on the screen. But this section we already did, and this is the pinout for our motor controller, the L298N motor controller. And so we already kind of did this code, so I'm just going to copy and paste this in from our other code that we have, because that's just easy enough to copy and paste in. Some of this stuff we're going to be able to copy and paste from the other codes, and some of it we're not. But now we have the IR remote commands, and I ended up recording that all for you. It should be the same for your remote. If it's not, we'll find out. But if you're using a different remote like this one, it's going to be completely different. But if you're using the one that came with the kit, it should be the same. And so for this, we're going to have to create a new section here, just up top before everything else. And I'm going to comment this out, and I'm going to go IR remote commands, or command codes in the NEC. All right. So this is the command codes. And so we're taking in that command, which was like the 0x46, the 0x44, the 0x40, or whatever it might have been, 15. And we've got to assign those to, hey, this is the command for up, this is the command for down, this is the command for left, right, and this is the command for OK. So we can pull up those things and and map those things to what we actually want to do here. So we're going to use something we haven't used before in this. It's called, give me a second here. It's like an 8-bit character. So what we're trying to do is we're unassigning 8-bit integer. And so because we only want this 8-bit integer, we're going to call it, and it's a uint 8 _t, and you'll see that here in a second. But I'm going to say constant because I don't want this thing changing. So if I want nothing to change, so I could go constant int, and that int that I put down will never change. But in this case, I don't want these things to change or randomly change on me. So I'm going to say constant, and then uint 8-bit right there. This one's a 16-bit. We have a 64-bit, but we're going to use the 8-bit for this. I'm going to say command uppercase CMD up. Actually, I'm going to do uppercase here. Up. I'm going to say equals 0x46. That's the one I logged for up. And we're going to call, this one's going to be for forward. All right. And then we have another one. We have constant. So const. I'm going to say another uint 8-bit. I'm going to say that command underscore down equals 0x, and I think that was a 15. Yep. And this one's going to be reverse, right? Yes. Double checking. 815 is yes. Okay, reverse. Yes. All right, and then we have constant uint another one, and that's also going to be a command underscore, and it's going to be left. And left was 0x44. Turn. All right, and so essentially I can do this again. I'm going to grab these two and just modify them. I'm going to say copy, Control C, and Control V, and I'm going to say right. I'll uppercase that. And right was a 43, and this is a right turn, and this one is command button OK. It's OK, and that was a 40. We're going to call this stop. All right. So now we have our command codes from our NC remote, NEC remote. The other thing we want to establish here, this is optional, but we know that the address for this remote is a 0x0. And this will help us ignore other remotes or other signals that come in at a different address. And so we can just say, we can call this another constant. Not uppercase, U int 8 bits. And we're going to call this expected address. All right, let's call it that. That's fine. And that was a 0x0 expected address, right? So it expects this address, and this is optional, but this is the address of our remote. So that we won't get confused, this system will only pick up addresses or remotes that have this address. I'll end up using that. All right, and I think I programmed this. We had something really similar to this, I think. I'll just type it out. We're just going to do speed settings next. So I'm going to go speed. All right, and under the speed settings, I'm going to establish some integers. I'm going to call them drive PWM. I'm going to call that, I'm going to set that to like 200. You can set this to whatever you want. It's that range between 0, I'll put this up here. These have to be between 0 and 255 for the PWM controls. But this is our forward and reverse speed for our drive motor. So FWD and rev speed. And then we can establish a top speed for turning, because I don't want this turning too fast on us, so we can actually control it. And I'm going to say turn PWM 170, 150. Turn a little slower. And this is our turn speed. And then finally, int max, I think we had this on the other one, PWM equals 255, so we don't go over that range. All right. And then we have those, I think we did this the other one, it's a quick flip of direction if it feels wrong. It's that Boolean true-false thing. We can flip direction of things, of the motors left and right. So rather than flipping wires. All right. Now we're going to set up the auto stop that I talked about for the button hold and the button press. And this is going to be our little fail-safe, so that it stops, auto stops, if no IR is recently seen. So I'm going to say unassigned long, in this case, so long character or long integer, I don't remember. Doesn't matter. Last IRMS equals 0, and then constant. What are they doing unassigned long here? And long. We're going to name this IR underscore time out in milliseconds equaling 250. Let's just slap that on there. 250 milliseconds. All right, we'll use those later for a little timeout. And then we're going to establish our drive state here. So we're going to establish another little drive motor thing section here. And so just follow along here. And this is a drive state, whether it's driving forward, back, turning, whatever it might be. And we're going to say, we haven't used this yet. And we're going to call this drive motor. or drive mode, sorry. Drive motor is our void that we're going to create right after this. All right. In this, we do that. Sorry, wrong one. I want to do curly brackets here. I want to do mode. Let's do mode stop, comma, mode. I'm going to do all uppercase here. Underscore FWD, comma, forward. I'm going to do a mother mode for reverse. Rev. I'm going to do another mode for turning left. Turn. Come on. Underscore L, comma, and then mode underscore turn underscore right. And we're going to close that with a semicolon there. All right, that should close that line, and then we have to do a little drive mode here. We're going to say drive, lowercase drive mode equals mode stop here. Close that. And then drive mode. Last mode. I'm going to do uppercase mode. Mode stop. And close that. All right. Now we're going to jump down into the void. And I think we created this void. I think it's, yes. It's just the same exact thing that we used before in our other one. So we can do a copy and paste over. And this is just that drive motor, the E1, N1, N2, EN, the value, with the max speed cap and our stop, coast, with our reverse and forward. So we already programmed this, and we can steal this from our other code. And then we're going to move on, and we got to create a new apply mode to motors. And so this is where we applied the stop or the forward or the reverse or the left turn or right turn to our drive mode. And we are establishing these items. Yes, we're establishing our speeds to those applied modes in this case. So we're going to say void. I say apply. We're going to call this apply mode to motors. Yes, and then we're going to go like that. I'm going to say drive mode M. And then we have to put some curly brackets down because we're going to be working inside these curly brackets here. So I'm going to put some enters here because this is we're creating a little void thing that we're going to use here, a function, establish this whole entire little void thing. And did we do something like this before? I don't have that code pulled up, I don't think right now. Oh, we did. I do. We might have did something really similar. So we used this in our last one. I just copied that over. Nope. All right, so we're just going to go ahead and program this void. So rather than copy it. So we're going to establish two things. We're going to go left command, right command. So we have to establish that. We're going to say tab int left cmd equals 0. I'm going to do the same for right cmd. We might have did this for some other function that we were using or established in the other code. That's why it's looking familiar to me. If. So these are just going to be a bunch of if and then else statements. In this case, if mode stop, we just want it to stop. So no spinning the tires. So I'm going to say if the mode, drive mode, equals mode stop, right? So curly brackets down. In this if statement, I want it to say, hey, I'm going to say copy and paste here because I'm literally doing the same thing. Hey, left command, stay 0. Don't apply any number to you, right? And then the same thing with right command. If you're stopped, if the mode is stopped, the mode drive mode M is stop mode. Don't apply any power to right or left, right? And then if we go on else, if, so then if mode equals mode reverse, do a little curly bracket here, put some enters, where you want this to do something. We want it to go reverse, or we want it to do left command a PWM and right command a PWM. So then I'm going to go like this. I'm going to say, actually I can go like this. I can go like this. I'm going to end up doing this. So let's copy and paste this. Perfect. I'm going to tab that. So we're going to say, hey, left command, go with speed, this speed that we set it to. So drive speed. So where was I here? So I'm going to say, hey, go drive PWM. So I'm just setting this one to that 200 drive PWM, or whatever I set my drive PWM. Same thing to here, because we want these motors to drive equally when pressing the reverse button. All right, and then we're going to do this again for our forward. Just going to switch this out. FWD. So we want if M equals the drive mode forward, set right and left command motors to that PWM of whatever we set this to. So we want those motors just to move forward or reverse. Oh, shoot. We want it to remove reverse, so we have to put the negatives. Forgot that. So these will move negative in the negative direction, what we set it as, and the forward will move the forward direction as we set it as, right? Equally. Then we can do this again and do this for left and right. So we're going to do another if-else statement, and we're going to do the left turn here, turn left. And for this, we want one wheel to turn one way and the other wheel to turn the other way. So it turns. So it turns and pivots. We'll do the same thing here. So, and we want that to move slower, so we're going to use the turn PWM. And we're going to need to go negative in the right, left, and we're going to need to go positive in the right. And the opposite is for the right turn. So just like that. And we're going to copy and paste this again. I'm going to say this. And then I'm going to say right turn here, and I'm going to flip these out. I'm going to say negative down here. All right, and so that takes care of our turns. So now we have it turning one direction or turning the other direction, and we have the going forward, and we have it going reverse, right? And we have it stopping. And then we just need another failsafe. We'll just do an else statement here. If nothing, if else, right? If you don't see anything else, we don't have a condition here. We just have a statement, and we're going to use this same statement right here. So if you're not going to see anything, just stay still. All right, and that should jump us out of that void. I'm pretty sure we're good. No, oh, sorry. Double checking. Yep. Okay, so now we're done with that, commanding those motors. We're going to do an inverted left-right. If our motors are opposite here, we're going to fix that right here. If establish in, there we go. Invert left command will equal. So this is that true false if statements, I think. Yep. Give me a second. Yep. If we put these as true, then this code will run. So we're going to say negative left command, close it. We're going to do the same thing here. This is another if statement. If right. Let's say right command negative right. So if this Boolean is true, if we go back in here and we say, hey, our motors, instead of actually wiring it physically, we can just fix it with this Boolean true false, and then we can end up with the correct turning directions of our motors. All right. And then finally, we need to, I think we did this in our other one. Give me a second. I just want to double check that I can copy this over. Yes. So we're going to want to take these two lines and copy that over here. And so we're just going to copy those two lines from our joystick and put those right down here. Those motor commands. Drive motor that and drive motor that. Keep it super simple. We don't have to rewrite them. So that's it. That's it for that void, applying mode to the motors. And then we can jump out of that, making sure that everything is inside this bracket right here. So that and that. Everything's inside that void bracket. So now we're jumping out of that. I'm going to put some enters here so we can see further down. And we've got to do some mapping of the IR command bits to the drive motor or drive modes. So we have to say, hey, we're going to map this button press to the commands, right? Or the commands to the button. Yeah, you get what I'm saying here. So, just going to put that down here, Control C. All right, so we got a map here. And to do this, we're going to call up the drive mode that we established there. We're going to say command. We're going to say command to mode. We're going to call this command to mode. And we're going to say this 8-bit command. We're going to establish that right there. And we're going to establish this little function. And we're in this little function, we're going to do a bunch of other if statements here. And so I'm going to tab this in so we can get some organization here. I'm going to say if this CMD equals CMD up, then we're going to return forward mode, right? So if we have the commands equaling the command up, we're going to have it return and do the forward mode. So forward, which is this. Boom. Right? And so we're going to say return mode forward. Close that. And then we're going to jump out of that if statement. And we're going to do another else statement. I'm going to hit an enter here so we can get inside these two brackets. We're just coding inside these two brackets for this command to mode. All right, I don't know what happened there, but I lost my video. So we were just here. We were doing those if and else statements for the command up, command down, and just mapping commands to modes. So when that button's pressed, these things are returned, right? And so that was just a simple else if statements. You can take a look at this, and it's just command equals the button press, and then return what we're doing there. Whether it's up, we're going mode forward, or if it's an else if, we're doing down, we're going mode reverse, and then the else if for left and right turns here. And then also the command button for the OK, and so that's a stop. And then we have the return mode for unknown buttons, is keep in the current direction, right? And so once we finish that mapping, we have to just jump out of that, make sure it's all inside that bracket there. That is inside this there. So all of that, we jump out of that, and we're finally on to our last two things, which is the void setup and the void loop. So we can run all this code. So we're going to say void setup like we normally do. Normally we don't have to type this, but we deleted it, so we have to. So I'm going to put some enters there. I'm actually going to scroll down here so we can get that in the middle of the screen for you. So we just have this void setup. We're making sure we're inside those two brackets there. And we actually can copy over a decent amount here. In the void setup, again, we have to do this pin setup, the pin establishment with the pin mode and the analog writes and all that other stuff. And then serial begins if we're doing any of that. But in this case, we have those two. We have the pin motor pins, and we have some analog writes to A and B, EN, A, and EN, B from the other code. And so I'm just going to copy that over. So that's just copied over from our other code in the void setup section, is that pin mode in the analog writes, because we want to write it just to stop in the beginning. Don't do anything right on startup. And then we have this IR begin, because we have to begin that with the IR receiver dot begin. We can take that from our other code. And so this starts the IR receiver with the enable LED feedback. I can take that. And then we have to just add something to this startup. And that's going to be this last IR MS, right? And we want this equal to milliseconds. And we're just going to do that. And so that's just initializing our fail-safe timer that we created right there. So that's all that's doing. And that's done. We have our setup done. It's just as simple as combining some stuff from our one code, combining the thing from the other code, and then adding this little fail-safe timer. That's it. And we're done there. Now we can jump down into our void loop, which we're going to have to establish that because we don't have it written this time. So we have to go void loop. And then we have to do our little curly brackets, and we're going to put some enters between those two curly brackets because we're going to be coding inside those two curly brackets right here. And most of this is going to be new. Most of this, all of this is going to be new because we created new functions to use. And so all of this is just going to be one if statement and then our applied mode to the motors, right? And so we're going to, if the IR signal arrives, we have to decode it. And then 2, we are only accepting our addresses and our code, blanking on the protocol, NEC protocol. So we have to establish that, and then we can jump out of that, and then we can do the failsafe, and then we can apply it all to our motor drives. So that's what we're going to do. There's 4 sections to this, and so I'm just going to copy and paste this in quick. So the first thing we have to do is if IR arrives, what are we going to do? We're going to establish an if statement here. I'm going to say if that IR, this is lowercase receiver. There we go. Dot decode. Can't do that. I mistake again. Decode. Go like that with a double bracket. If that arrives, if the decoding arrives, you're going to do this thing inside this brackets, right? If it arrives, we're going to run our millisecond thing. So we're going to run our, I'm going to say last IR millisecond equals, well, let's just copy it from here actually. Just run this. Boom. And what's this doing? This is update the last scene for fail safe. All right. Then we can jump out of there. Now we can read in the decodes. And so we can read the code. Okay. So we're going to say auto. I'm going to say protocol. Equals IR. There we go. IR receiver. This is a decoded right there. IR data is uppercase data dot protocol, and we're gonna do this again for our address, which is in 16-bit, and then our 8-bit. We're not actually, we are using the address, but we're gonna have to change this. So this is gonna be int 16-bit. We're gonna call that address. Or can name it different. We don't want to name it the same as our other function because that'll mess things up. And then we have to do IR receiver decode address. There we go. And then we're going to do a uint for the 8 bits. There we go. We're going to call that CMD. And we're going to put command here. And I'm forgetting to close these lines. That won't be good. All right. So we're still inside this first if statement. And then we have a Boolean right here. So we're going to do, give me a second here. We're going to say bool is repeat equals, sorry, just copy and pasting this over so I don't have to do this. IR data flags. And IR data, just follow along. Flags, IS, repeat. There we go. IR data. Yep, we're good to go there. All right, and then we can do our second section here, which is only accepting the NC and the address, the correct protocol and the correct address. And so this starts with another if statement inside that first if statement. We're still inside this bracket here. So if protocol equals NEC and address, there we go, that function equals expected address, there we go, then run this. And in this, I'm going to say space, so I'm going to do the curly brackets, I'm going to put some enters. In this, we're going to do a repeat frame, if statement, if the repeat frame. So we're going to do an if, dang it, I can't do this, is repeat, run this little code here, mode equals the last mode, close that, and we're going to jump out of that. We're going to do an else, if anything else, and this just has a statement. Nope, I don't want a condition. I want just an else with this statement. Mode equals command to this CMD, close that line, and then we're going to go last mode equals mode. All right, so there we go. We've got that done. We're still inside our if statement here. And then after that, we're going to jump out. Well, sorry, we're going to do one more last thing. We got to do an IR resume. We got to clear the buffer here. We're going to do IR receiver dot resume. Not seeing it there. And we got to close that. All right, so now we've got that. We are ready for the next IR packet, and it will run that again. We're going to decode again. We're going to run this decode again. All right, so then after that, we're going to run our little failsafe. 3, run the little failsafe. It's going to look for that, but if we do haven't had any IR recently, we're going to just shut it off. And to shut it off, we're going to do another if statement here. If millis, there we go, minus the last IRMS is greater than IR timeout MS, then run this code. And it's just going to run this mode to stop, right? And so we're going to go like this. We're going to hit enter. We're going to say mode equals mode stop. And we're going to put a stop there. All right. And then we have our final item, which is just applying the motors, which is here. Number 4. We're going to delete. Okay, I want this organized just like this. I'm going to make sure that this, so that, yep. Okay, so we're just in this, the final loop here. Correct. Okay. So just making sure that I'm encoding this correctly. Okay, so then we go apply. Mode, drivers M, we're going to go say mode because we're establishing mode here. So it's just going to shove whatever we established mode as. Boom. It says, hey, last mode. All right. It's just shoving those things in, and then we're going to shove this mode into this motor driver to apply to the motors. And then we're going to say, oh, don't forget, got to close that line. And then we're going to say delay this for 10 seconds or 10 milliseconds. 10 milliseconds, and then we got to close that line. And that's all of our code. So we can go ahead and compile this. I'm just going to check that I got everything. Oop, oop, oop. Left CMD, right CMD. Oh, okay. Maybe this is the issue because I have double CMD. Uppercase. Error. I think it is uppercase. So we got to do a C here and a C here. Is that right? Compile. Okay, cool. So it's compiling correctly. I'm going to go ahead and plug in my car. I'm going to say, hey, here we go, car. Plug this thing in. I know this is a long video, but we've got our car plugged in. We're going to select our correct Uno here, and we're going to say upload. And it's uploading. And it's done uploading. So I'm going to unplug this. I'm going to find my remote, wherever it might be. Shoot. Oh, found it. Found it. So, okay. So I have this. If I press forward, I gotta kind of turn it on, huh? That makes sense. I gotta put the power to it. So I have this, and I press the button. Should go forward. Both wheels are going forward. Both wheels are going in reverse. When I press the reverse button, the wheels are going to be turning opposite directions when I press the side button here. Oh, come on. Turn, turn. So just cool little things. I'll show you in our video. I'm going to pause this and I'll get you set up. All right, so I've got my remote here. I should be able to press forward, reverse. Come on. There we go. There we go. We got a working car. And you kind of have to point the direction of that little infrared at your little infrared sensor. So it works better that way. So just that. There we go. And if you need any help, we'll see you on class this next Friday. So best of luck.